Hello everyone, welcome to another episode from Chedexcel. Today we are going to talk to you about atom economy and percentage yield. So first we will look at percentage yield. Now in a chemical reaction, the reactants react to give products, but the products we obtain might not be the expected value. Due to the various reasons, the obtained amount or the obtained mass, the volume would normally be less than what we expect. Now, during the chemical calculations, what we always measure is the expected value, right. We say 20 grams of sodium reacts with oxygen to produce 35 grams of sodium oxide. So, that is the 35 gram is something we obtain, we expect sometimes, but we might not get that much. So, always percentage yield will be less than the actual value or the expected value, unless if you are measuring a precipitate. Sometimes if you get a precipitate, the mass of precipitate would be higher than the expected. The only reason for that is the precipitate is damp or it is not dried enough. So, those stuff they have asked in unit 3 questions, but generally the percentage yield is less than the actual value. So, percentage yield means simple one, percentage yield would be actual value or expected value, or we can say sometimes the theoretical value into 100. That is what we say as the percentage yield. So, in calculations sometimes you will be given the actual value and you have to find the expected value and then find the percentage yield. Sometimes you will be given the yield and you will be given the expected value, then you will ask what is your actual value. So, this percentage yield comes for both MCQs as well as writing part as well. If this comes to the writing part, normally it is a 3-mark question, but if it is MCQ, just 1 mark. And this is not only for unit 1, you get in for unit 2, unit 3, unit 4, 5, 6, any unit you can get this one. So, we will see how we can do the percentage yield calculation. So, we will do 2 past paper questions first. So, this is the first one. Right. It's a recent past paper. It says a mass of 2.5 gram of sodium chloride reacts with excess lead nitrate solution forming lead chloride with yield 95%. Mass of lead chloride formed. So, formed mass means the actual value. So, they are asking the actual value. So, this is how we can do this. Normally, to find the expected value, we normally use the same method we use to find the amount. So, I told you when you do that part in chemical calculation, what you have to do is first you have to find the amount using the given data, use the molar ratio to find the expected amount, then you have to convert into the required quantity. That is how we do the calculations. So, here also the expected value we have to find. So, there is 2.5 gram sodium chloride. So, that is your given data. So, you have to divide by mass or molar mass. So, sodium chloride molar mass is 58.5. So, that is the sodium chloride amount, and that amount equals 2.5 over 58.5. I just keep the original answer, always keep the original answer in these calculations, 5 over 117. So, reaction is 1:1, right. Sodium reacts with excess lead nitrate, sorry 1:2, forming lead chloride. So, lead chloride equals half of this value. Why? The ratio is 2:1. 2 sodium chloride gives you only 1 lead chloride. Then you have to find the mass. So, mass of lead chloride would be, then these are simple calculation, amount into molar mass. So, half into 5 over 117, that one into molar mass of lead chloride 278.2. So, that answer divided by 2 multiply by 278.2, 107 over 18. So, that is the expected value. Therefore, percentage yield would be, question asking the what is the percentage yield, what mass of lead chloride is formed. So, is formed means as actual yield is given, yield is 95. So, 95 equals actual value is x, expected value is 107 over 18, that one into 100. So, that gives the x So, this answer cross multiplication 295 divided by 100, answer is 5.64 647. So, answer is A, 5.65 grams. So, that is an MCQ, but if this is asked in the essay paper, this normally give you 3 marks. So, that is the first one, how we do the percentage yield calculation. Using the given data, you have to find the amount, then using those amount, you have to convert it into the required moles and then molar ratio, then you have to convert it again to the required quantity. In this case, the required quantity is converted into the mass. Okay, so if I tell it again, so mass over molar mass 2.5 over 58.5, you get this one, and you find the mass of that. That's a you divide by half because that is the molar ratio. Then you multiply it by this. So that's how you get this one. That's the very first one. We'll do another one. It's MCQ. This is also an MCQ. So we'll do another MCQ. So cyclohexene may be prepared by the dehydration of cyclohexanol. The reaction is given. What mass of cyclohexene can be made from 12.5 gram of cyclohexanol if the yield is 51.2. Same type of question. So amount you have to find first 12.5 divided by 100. Now this case reaction is 1:1. So the expected amount should also be the same. So expected mass would be amount into molar mass, 12.5 over 100, molar mass would be 82. So that is the expected mass then. .25. So that is the expected mass. The actual mass can be made. So percentage yield is given, which is 51.2. That is actual value they are asking X. Expected one is 10.25 into 100. So in this case, X would be 51.2, 5.248, again answer is 5. That's how. So these are not that hard, it's very easy questions. So that's how we find the percentage yield calculations. There are different types. When you discuss papers, you will get those stuff as well. So the last part of this calculation chapter, that is atom economy. Now atom economy, the idea is this. Now scientists thought that sometimes we use reactants to give products, but not all the reactants are given the desired product. For example, let us say this one, sodium reacts with chlorine to produce NaCl. Right. Here all the reactants are used to give the NaCl. So all the atoms are being used up here to give the desired product. But if you use sodium hydroxide and HCl to give NaCl, hydrogen we have in the reactants are not going to give the desired product. In this case, desired product is NaCl. So some amount or some atoms are not being used up to give the desired product. In a way, in environmental case, it is not that good, because we might say those are pollutants. In this case, it is H2O, it is not a big deal, but there are many other chemical reactions that after we get in our desired product, there are many other pollutants being formed. So we have an idea about atom economy, which says how many atoms of the reactants are actually being used up to give the desired product. So in that case, the concept of atom economy is very widely used. So what is the idea or the formula we use for the atom economy? Atom economy is this. Atom economy is molar mass of desired into number of moles divided by total molar mass into 100. That is the atom economy expression. Molar mass of desired into number of moles divided by the total molar mass. So let us say some example. Here it says Calculate the atomic economy by mass for the formation of germane. So, this is a reaction. It's given a big reaction. So, GeH4. Germane is 72.6 germanium plus 4 hydrogens. So, atomic economy is 4. Number of moles again here is also 1. So, you can use the reactant side or product side. I am using the product side again. GeH4 72.6 plus 4 plus 2 sodium hydroxide. Sodium is 23, oxygen and hydrogen is 17 or 16 plus 1, that one into 2 plus NaBO2. Sodium is again 23, boron is 10.8 plus 16 into 2. That one in everything into 100, right? You have to multiply this by 100 again. So, let us say how much you would get here. 72.6 plus 4 divided by 72.6 plus 4 plus 23 plus 17 plus 23 plus 10.8 plus 32. So, you get 34.4. So, that is how we do the atom economy. So, atom economy and percentage yield very commonly come for the MCQs as well as these equations, and percentage yield you always doing the calculation, the expected value is the what you normally do in chemical calculation. The actual value would be the different value. Usually it is lower than the actual expected value. And atom economy is simple concept. We see how many atoms of the reactants are actually being converted to give the products, right. So, if this is helpful, give a thumbs up and consider subscribing. Thank you.